everyone. Today I'm going to discuss the Physics 2211 Lab Report 3, which is black hole. Let us start by looking at the table of content. The table of content starts with introduction and the purpose, followed by the computational model 1, followed by its result. Then it is followed by the computational model 2, the code as well as the result, and finally the sources of error, what if, and what else. The purpose of the experiment is to first analyze the motion of a star to determine the mass of a black hole, and second, use the calculated mass of the black hole to determine the initial velocity of a spaceship to get it close enough to the black hole without crashing and still being able to leave the system. The key ideas here used are first, the Newton's second law, which states that the rate of change of momentum is directly proportional to the net force applied. Second, the force of gravity pulls the object with a mass towards each other. And third, the parallel and the perpendicular component of net force. So in part one, the system is the star and the surrounding is the black hole in space. Whereas in part two, the system is the spaceship and the planet and the surrounding is the black hole and space. Introduction and formulas. So the computational model was created by a script code and the code is provided as we go along. The formula used is force of gravity is equal to minus mg j hat, whereas the j hat presents the direction, which is 0, 1, 0. G, which is equal to g me r square, where capital G is the Earth's gravitational field, which is 9.8. Third, the Newton's second law, which states that F is equal to ma. Fourth, the velocity update formula. And fifth, the position update formula. Now we can look at the two components of the net force. The first is the parallel component, which is the component which is parallel to the direction of motion. And second is the perpendicular component, which is the component which is perpendicular to the motion. The formulas for both of them are shown below. So let us start by looking at the initial conditions for the model 1. The initial conditions of model 1 are G is 6.7 into 10 raised to 11. The mass of the star is 2 into 10 raised to 30, and the time interval is shown below. We'll first start by looking at the code of the model 1. The code for the computational model 1 is shown below. I first calculated the velocity using the first while loop, whereas in the second while loop, the momentum was found. Then we found the change in momentum, which is dp by dt, and then we found the parallel component of the momentum. When finding the parallel component, we could find the perpendicular component by subtracting the dp by dt minus the dp by dt of the parallel component. We calculated the mass by the gravitational equation as shown below. Now let us look at the results. The results of the first part shows that the magnitude of the net force at final position, parallel component, and the perpendicular component is shown below. The main result, which is the mass, came out to be 1.63 into 10 raised to the power 34 kgs. Now let us look at the model 2. The computational model of the initial conditions of the model 2 is derived from the first model. Net force at the planet as well as the spaceship is found by the gravitational interaction. We then use the velocity update formula and the position update formula in order to find the velocity and the position at that initial position. The initial velocity was chosen by a trial and error method until we got the accurate value. The code, all of the three codes are shown below. Now, let us look at the results. After calculation of the 60 minutes showed the distance of the ship from the event horizon was 1.27 into the 10 to the power 11 meters. Now, let us look at a few of the sources of error. Sources of error could include inconsistent approximation or inaccuracy. As we used an trial or error method, we could have still found a closer velocity, which would give us more accurate prediction. What does that mean? In your analysis, you discuss how the net force and its parallel and perpendicular component are different from the rate of change of momentum and its parallel and perpendicular component. What I feel is that mathematically they both are the same. However, the change in momentum is easier to measure. For the net force, we must know each individual force outside force in order to find the net force. Whereas for the rate of change in momentum, we just need to know the system change in velocity or momentum. What if, instead of deciding to take a quick look at the black hole and leave, we decide to want to enter into the orbit around the black hole? What initial velocity would your spaceship need to have in order to enter the space? After using calculations, the initial velocity as well as the initial velocity has been shown in both x and y direction. Thank you.